Welcome to numerical integration. So the idea here is sometimes we wish to take an integral but do not know any antiderivative of the particular function. Right? So sometimes we wish to take an integral or a definite integral. But we don't know an antiderivative. And if we don't know an antiderivative, then we can't use the fundamental theorem of calculus. So instead, what we do is we try to approximate our definite integral by approximating it with various shapes. So instead, we approximate the area. So recall previously when we were talking about definite integrals, we used rectangles to do our approximation. So again, previously, we used the Riemann sum to approximate the definite integral. With n rectangles. Let me update my screen. And our rectangles had heights based off of either the left side of the little interval or the right side. So the rectangles had heights based off either the left side of the interval or the right. But essentially, the height of each rectangle was based off of one x value within the interval. So the question becomes, what other forms of approximation can we use? So again, the rectangles were based off one x value within the interval. We will do two other versions, one which will be based off of two x values from each interval. So we will have what we will call the trapezoidal rule. Which will use two x values from each interval. Again, the trapezoidal rule will use 2 x values from each interval. And we'll create trapezoids instead of rectangles. And the other thing we will use will be Simpson's rule. Simpson's rule will use 3 x values from each interval. And essentially what we'll do is we will try to model our function f of x with little parabolas instead. So we'll model it with segments of parabolas. So as a general rule, each time we add more x values to incorporate, we should get a little more accurate with our approximations. Likely we'll need fewer intervals the more information we use in each piece. So in the next videos, we will look at a little deeper into the trapezoidal rule and Simpson's rule.